So today we're going to look at equilibrium, balance, motion of the head, movement, things like that. Sense of equilibrium consists of two different parts. There is static equilibrium and dynamic equilibrium. The organs of static equilibrium help to maintain the position of the head when you're standing still. So when I think static, I think stay or stay still. So the organs that deal with static equilibrium work or maintain when the head and body are standing still. So it does not deal with movement. Organs of dynamic equilibrium help to maintain balance when your head and body suddenly move, rotate. Equilibrium, every body reacts to equilibrium a little bit differently. I myself hate little spinny rides, like the tilt-a-whirl. I hate because it just simply spins. When I was a little kid, the merry-go-round, if I stayed on it too long, I would feel sick. I don't mind big up and down roller coasters and things like that, but when it comes to rotating, obviously that bothers my dynamic equilibrium. So when we look at static equilibrium, they're located within the vestibule, inside of the inner ear, inside the utricle and saccule, which are basically just expansions of that labyrinth or those tunnels that we had looked at on the diagram probably last time. A macula is what holds the hair cells or consists of these hair cells and supporting cells. They lie inside of this utricle and saccule that are inside of the labyrinth. And this macula then has those hair cells that are going to feel or react to and sway with the liquid that is inside. So the hair cells contact that gel-like, liquid-like material holding otoliths, which are little bone-like structures, tiny little bone-like structures. Otto deals with bones. So what happens is gravity causes this gelatin, and then the otoliths would be like tiny solid particles, to shift and move, and that causes these hair cells to bend. And that generates a nervous impulse. So when these hair cells sway or bend a certain direction, that's going to cause an impulse in your nervous system. Impulses travel to the brain by way of the vestibular branch, vestibulocochlear nerve. So this is the nerve. Cochlear, remember, deals with the cochlea, the snail-looking part inside of your ear. Vestibulocochlear nerve comes from both the vestibule and the cochlea, indicating the position of the head so that your brain can decipher what position your head is in. So if I am sitting upright, my head is up, here's those little hair cells, here's the gelatin material, and then here's those solid otoliths that are inside of it. So the hair cells are standing straight up. When you move your head forward and bend it down, notice how obviously gravity is going to cause this liquid and solid to move down also. Your hair cells bend and flow with that, and then that impulse from the nerve or from the hair cells is picked up by a nerve, and it's going to be carried to your brain. Which is why sometimes if your head tilts quickly or something like that, which causes dizziness. Dynamic equilibrium, the three semicircular canals detect motion, and then they aid in balancing in the head, and like I said, sudden movement that sometimes can cause dizziness. Sometimes when you stand up too quick, you'll get kind of dizzy. Usually that deals more with like pooling of the blood not getting to your head quite quickly. But other movements can deal with your brain and how it's picking up your movement. So the organs of dynamic equilibrium are the cristae ampullaris, and they're located in the ampulla of the semicircular canal. So different parts of the ear deal with your different types of equilibrium. Static equilibrium is in a completely different part than your dynamic equilibrium. Hair cells here, though, work the same way. The hair cells are going to extend into a gel, and it's called a cupula, and that deals with the shape of what they extend into. So what happens, rapid turning of the head, rapid movement of the body is going to generate impulses inside of that cupula, and the hair cells in there are also going to bend again with the moving endolymph, which is the fluid that's inside of your semicircular canals. Mechanoreceptors or proprioreceptors, they both mean the same thing. Mechano deals with movement, structure, associated with the joints, and then the changes detected by the eyes also help to maintain equilibrium. Sometimes, if you're riding a ride at a carnival, the fair, or whatever, if you close your eyes, you don't get as dizzy. Your eyes and your equilibrium work together. In the lab, we do a little activity where you spin in a circle on a chair, and if you stop a person quickly, their eyes will continue to go the direction that they're spinning. Impulses travel to the brain, same way, the vestibulocochlear nerve. Basically, this nerve is going to carry all information from your ear to the brain, indicating again the position of the head. So here you can see these cupulas. It's cup-shaped. That's where the name comes from. So here's a little cupula. It has the fluid or the gel that's inside of it. And these are the hair cells that extend from the nerve that picks up that information. And that's probably all that I need to point out there. So here it is just showing that when you move your head, this little cupula that's inside of your semicircular canals, it's going to also rotate and move, and when that moves, the hairs are going to bend, and that's how motion is picked up by those nerves. Semicircular canals. And that's where we'll stop today. Next time we'll get into the sight in the eyes, which is a large portion of the chapter.